How fast are you moving right now? I mean, really. It sounds like a simple question, right? But the answer is going to take us on this incredible journey from the simple spin of our own planet all the way out to the edge of the known universe. So, let's get into it.
Right now, wherever you are, sitting at your desk, on your couch, you probably feel perfectly still. I mean, the ground isn't shaking, the air feels calm. But what if I told you that feeling is a complete illusion?
The truth is, you are on an unbelievable cosmic joyride at speeds that are almost impossible to imagine. And the clues? They're hiding right there in plain sight. You see them in the sun moving across the sky every day, and the stars wheeling overhead every night. It's time to start peeling back these layers of motion.
Okay, so first things first. We have to understand the big question. How can you be hurtling through space at these insane speeds and not feel a single thing?
This analogy is absolutely perfect. Think about being on a really smooth flight. You can get up, walk to the bathroom, pour a drink, and it all feels totally normal, right? Even though you're blazing along at hundreds of kilometers an hour. Why? Because everything inside that plane, you, your seat, the air you're breathing, is all moving together at the exact same constant speed. Well, Earth is just a much, much, much bigger airplane.
And this really gets to the heart of the physics. See, your body is an amazing detector for changes in speed. You know, when a car slams on its brakes or floors it, you feel that. But we are terrible at sensing smooth, constant motion. And thankfully, gravity is like a planet-sized seatbelt, keeping all of us, the oceans, the entire atmosphere, strapped in and along for the ride.
All right, let's start our cosmic zoom out with the very first layer of motion, the one that gives us our day and night.
So let's start with our daily spin. If you're standing at the equator, the Earth is rotating at a mind-boggling 1,670 kilometers per hour. To put that in perspective, that is faster than the speed of sound, way faster than any commercial jet you've ever been on.
You know, what's incredible is thinking about how long it took us as a species to wrap our heads around this. This simple daily spin, the most basic motion of our world, was actually proposed by brilliant minds like the Indian astronomer Aryabhata way back in the 5th century, long before Copernicus made it famous in the West.
But that spin, that's just layer one. Piled on top of that, our entire planet is also being flung around the sun on its year-long journey.
And our speed on this journey is almost 30 kilometers every single second. That is so ridiculously fast that you could travel from New York to Los Angeles in just over 2 minutes. So just think about the sheer scale of that trip. Every single year, you personally complete a 940 million kilometer lap through the vacuum of space. You're a seasoned cosmic traveler, and you've never even had to pack a bag.
But hey, even our sun isn't just sitting still. Our entire solar system is just one little speck of dust on a much, much bigger structure, our home galaxy, the Milky Way. And this whole thing is spinning like some kind of colossal cosmic carousel.
So get ready for another massive jump in speed. Our sun, and it's dragging the entire solar system along with it, is zipping around the center of the galaxy at an incredible 225 kilometers per second.
And this is where the scale just becomes mind-melting. Even at that speed, it takes our solar system over 200 million years to make a single lap. The last time we were in this exact spot in the galaxy, dinosaurs were the dominant life form on Earth. That one lap, by the way, is called a cosmic year.
So if everything is moving, the Earth, the sun, the galaxy, what can we possibly measure our speed against? Is there some kind of universal speed limit sign out there? Well, in a way, yeah, there is. And the answer comes from the very dawn of time itself.
I want you to imagine the Big Bang not as an explosion in space, but as a flash of light that filled the entire universe all at once. Well, that ancient light is still traveling through space today. It fills every single corner of the cosmos. We call it the Cosmic Microwave Background, or the CMB, and it is the ultimate cosmic backdrop for everything.
So how do we use this ancient light as a speedometer? Think of it like the siren on an ambulance. As it's coming towards you, the sound is high-pitched, right? And as it moves away, it gets lower. The same exact thing happens with light. As we fly towards the CMB in one direction, the light waves get squeezed, making that part of the sky look a tiny bit hotter or blue shifted. And the light we're leaving behind us gets stretched out, making it seem a little cooler or red shifted. By measuring this incredibly tiny temperature difference, we can actually calculate our speed relative to the universe itself. It's genius.
So what is it?
what's our grand total speed? When we measure the movement of our entire local group of galaxies against this cosmic afterglow, we find that we are moving at a staggering 627 kilometers per second.
And where exactly are we going in such a hurry? Well, it turns out we're being pulled toward a mysterious, gigantic concentration of galaxies and dark matter called the Great Attractor. It's this huge gravitational focal point, millions and millions of light years away.
So far, we've only been talking about constant speed. But remember how we said we only feel changes in motion? Acceleration? Well, it turns out that even on a cosmic scale, we can actually detect that acceleration with unbelievable precision.
The Gaia Space Telescope measured this effect, it's called aberration, by looking at millions of super-distant objects called quasars. As our solar system accelerates around the galaxy, the apparent position of those quasars shifts by a teeny-tiny amount. It's the exact same reason that when you start running, rain that was falling straight down suddenly seems to be coming at you from an angle.
And this is what they found, an acceleration of just 0.23 nanometers per second squared. I mean, that number is so small, it's almost zero. It's basically nothing. But the fact that we can measure such a tiny, tiny change in our motion as we orbit the center of the galaxy, that is just absolutely incredible.
So let's just recap this wild ride. We start with the Earth's spin. Then we add on our orbit around the Sun. Then you pile on our solar system's huge orbit within the Milky Way. And finally, you add our galaxy's motion through the universe itself. Each layer just keeps adding to our total speed, creating this grand, nested dance of cosmic movement. So no, you are not sitting still, not even close. You are a passenger on Spaceship Earth, on an incredible voyage that started with the Big Bang. Which really just leaves us with one last profound question to think about. What and where is our final destination?